very, I'm not going to lie to you. This is a very attractive math problem. It's oof. Okay, so we're going to take the derivative of x to the x. So in other words, we're going to set this up. Y is equal to x to the x. Now, I heard rumors from one of my TAs last year, because I worked this problem in BC last year when he was TAing for me, and then he went over to his AB teacher and said, well, this is obviously is equal to x to the x times x to the x minus 1. No, power base 1 less power. Okay, now question, what power of x is that? What's that times that? What's that times that? Just x, right. So the derivative of x to the x is equal to x. No, it's not. It involves using logarithms, which is what we have to do to both sides. Now, the problem with this one is we've got a variable in what? The exponent. So we've got a variable base to a variable power, which is why we can't use the power rule for this one. The base is not constant, so we can't use the 2 to the x rule or a to the x rule, and we also can't use the generalized power rule because the variable is also in the power. So we have to take, the only way to get a variable out of a power is to take the what of both sides. Yeah, the log of both sides, and not just log the natural log. Yeah, we're going to use natural log in this one just because it makes it shorter to write for no other reason. So my first step is I'm going to take the natural log of both sides. Matt.
So when if you multiply x by x to the x minus, or to the x minus 1, it comes out as x to the x. But my question would be, since the derivative in that case, if you use the power rule, would be the same as the original function.
Yep.
Why do we know that's wrong? Because with e to the x, though, it's the same.
Because neither one of those rules applies to that situation. The power rule only applies if you've got x to a constant power. X to the 1/5, x to the 5, x to the 7. Then you can use power rule. Power base 1 less power. If the base is a constant, but the variable's in the power, like 2 to the x, then we talked last time about that rule. But neither one of those apply when both the base and the variable are varying with x. Both of those change as x changes. We can't use rules for a constant like we could for a variable. Otherwise, the derivative of everything would be what? If it was the same rule for x as it is for 2, what would the derivative of everything, every single thing on the planet be? 0. Because what's the derivative of 2? 0, right. If we could treat variables and constants the same, the derivative of everything is 0, and this class takes about 8 seconds. The answer is always 0 if they ask you for the derivative. Don't ask why, just the freaking answer is always 0. And you know, no student would ever pay attention to that, because why would I want to learn something that's so trivial as that? And again, one of the goals of this class, you realize calculus is a great human achievement. Like, solving this problem is combining everything you learned about logs in pre-calc with the logarithm derivative rule that we just learned, plus the product rule. Like, it combines 3 things that really have nothing to do with each other, and that's why it's just such an attractive problem. In fact, first date material, if you're dating somebody who's in Calc AB or IB Calc, and you really want to impress both them and their parents, walk in. Don't give them flowers. Be like, hey, you guys got a whiteboard in the house? Guys, I want to show you what the derivative of x to the x is. And then dad, mom, they're inviting their friends over. They'll be like, look at this. Can I pick on some guy in this class? Who's going to be my guy who's taking on a date? Caleb. Caleb Blackburn's coming over. Right now, he's showing us the derivative of x to the x. Like, I remember that problem when I was in Calc. I like missed 10 points on my final because, like, come on over. Like, why is Caleb Blackburn coming over? He wants to take my daughter on a date. But first, he's going to impress us with this calculus ability. And then suddenly you have an audience of like 40, 50 people. And then suddenly you ask that girl if she can go out with you, and like her dad's encouraging it. He's paying for the dinner. He's giving you a $50 bill. No. Don't go to Arby's. Take her to the Flying House Steakhouse, or the Flying Horse Steakhouse. Impress her. I slip that one a lot. We want you to impress her. I want you to stick around. In fact, if your parents are going to the debate training that I'm giving on the 28th, that's one of the first things I'm talking about. Is I have a picture of like a boy smoking, drinking, and has a very loserish attitude, and then like a boy hugging a puppy doing calculus in the background. Yes, that you want that to be that. Okay, here we go. So let's continue. So we took the natural log of both sides. Can we take the derivative of both sides? Not yet. What can we do with that x up there? Yeah, we move it in front. Now, is it a constant? No, it's a coefficient, and it happens to be the coefficient is varying. So we have the natural log of y is equal to x times the natural log of x. Okay, that looks good. Stop and check out. Have I done anything with calculus yet? No, I want to find the derivative of both sides, but I'm just setting up some algebra first. Because this really is a sexy problem. And I have a feeling like if I was taking a test on chapter 3, this would be one of the things I had to do on that test of chapter 3. And I had a feeling if I was taking the AP test, they sneak this in there always. It might be part of a problem, but they always sneak this in somewhere, expecting that your teacher showed this, because this is one of those days that you realize, like, man, whoever thought of this the first time, like, they were freaking smart. And I understand this. I'm freaking smart too. All right, can we take the derivative right now? Yes, why not? What rules are we going to use on the right-hand side? What rules are we going to use on the left-hand side? ln and implicit, right, because we are taking the derivative of everything with respect to x. This is a y, so it's going to be an implicit differentiation. So what do? The derivative of y is, or the derivative of ln y is 1 over y times the derivative of the inside, which is dy dx. The derivative of this is going to be a product rule, so my f of x is x, my g of x is ln x. Somebody asked in an email last time, do I have to write this out every time? No, this is like, I was showing my Algebra 2 kids how to solve quadratic inequalities, and I just made a drawing that made it easy to see where it was, and then you could write out the answer. This is just making it easy for you to see what it is. If you can do it without it, that's totally fine too. What's the derivative of f? What's the derivative of g? Okay, so let's plug it in. Derivative of the first times the second, so 1 times ln x is just ln x, times the derivative of the second times the first, so 1 over x multiplied by x. There's my step of calculus. That's it. That's the only calculus that's in this whole thing, is that one step. Stop and check out. Questions on that? Questions on that? Yes, Cam. Yeah, it's ugly.
What is that?
Remember when I told you this is a really attractive math problem? It's got lots of curves to it.
Oh.
Can you graph?
Oh.
We will. Whoa. We'll get to the graph in a second, people. Don't be distracted by the squirrel he talked about outside. Let's talk about this first. All right, let's simplify. What's 1 over x times x? Okay, so ln x plus 1. What do we want to solve for? Okay, so what should we multiply both sides by? Y. Okay, so dy dx. Okay, are we done yet? No, we're not. We still got more good things to go. This is never the answer anybody will ever quote you, because it'd be really nice if it was just in terms of what? X. Now, do you have to do this step? Yes. Do you have to do this step? Yes. Question, why don't you want to leave y's in the final answer? Because those will not be the multiple choice answers on your test. They will replace the y's with x's. So in other words, now you got to go back. What's y equal to? Yeah. So dy dx is equal to x to the x times 1 ln x plus 1. Now, do you distribute that? I don't know. That really doesn't do anything good for me. There is your answer. The derivative of x to the x is x to the x times ln x plus 1. Great. Yeah. It is. It's a great problem, right? And think of being the first person who solved this. There really isn't anything hard to this. Implicit differentiation, the rules of logs from pre-calc, product rule. That's it. I don't know.
It's in the book.
I don't know. I don't look for the history of math. I look for the understanding of math. I'm not one of those teachers like write a 7-page report on Euler. No, that's
He's a pretty cool guy.
there are high school teachers that do that. Yes, in fact, I went to an 8. What's that? Oh,
He's important.
oh boy, he's gonna be your boy by the end of the year. Like he'll be the Nick. He's the Nick Saban of math.
He's a big guy.
So Newton invented calculus. He's the one that discovered the instantaneous rate of change. And Newton really brought us the limit. Other people had dabbled into it, but Newton's the one that like formalized all the stuff we call calculus now. Euler took what Newton did and expanded it. Like basically everything we cover second semester is from Euler. And does anybody watch the movie Hidden Figures?
Yeah.
Okay, in that, how does that lady, what's the actual thing she uses to solve to get the spacecraft back to Earth? Yeah, she uses Euler's method, which is an iterative process. Like we don't know anything except where this thing is and how fast it's going right now. How do we figure out where it's going to be at some later point? Well, all we do is break it down into tiny intervals using the derivative and the position, then using the derivative at the next spot in the position, derivative at the next spot in the position, and we can figure out where it's going to be later on without knowing anything except its initial position and its velocity.
That's a differential equation solving.
It, among other things, it does that, but most of it, what it is a linear approximation method, which is actually section 3.5 of this book. By the end of this class, you'll know how to use that. So yes, that in that book, that is his main accomplishment in math. is that method allowed us to use an iterative process to figure out where something's going to be if we just know where it is and where it's going.
He also saw the Riemann zeta function, zeta equal, s equals 2. He saw 1 over n squared equals pi squared over 6.
But speaking of fun things, let's graph this puppy just so we can see what it looks like. Go to the graph. Good news. What's the quick way to delete all this stuff? Because I forgot it. Menu. 4, 2.
1.
Oh, sure. Menu 1, 4. Okay. So I'm going to graph x to the x. So I go up to the tab and I go x to the x power. Is there anything you need this calculator for in this problem? No, you don't. Hit enter. Yeah, look at that. Because here's the weird part. Question, why does it do that? Because it's crazy oscillating. Like when we talk about a function that doesn't really have a limit, there's nothing it's getting close to over here. Clear, nice limit over here. Now, question, why is that? When it's negative, what do you have? A negative base and a negative power. So think of this. What's negative 1.5 to the negative 1.5 power? Yeah, that's why it oscillates back and forth between positive and negative, and actually bounces occasionally at imaginary numbers too. Because when you have negative 1 to the negative 2 power, you have an imaginary, excuse me, negative 2 to the negative 2 power, you have an imaginary number. Yes, that's why it crazy oscillates. Now, let's have fun with the calculator. Let's see if we can do that. Get out of here and go back to the main menu. Let's see if we can do this. Let's find the derivative. Go to menu, go to calculus, go to derivative. Let's find dx. Let's see if it can even do this. Maybe we're smarter than the calculator now. X to the x power. Oh, that's not worth $140. I don't know what it is. Yeah. So anyways, there it is. I'm letting you know. That's probably a great human achievement because now we have a variable base and a variable power, and we can find out how fast it's going at some point. Great. Caleb.
My graph is not showing the crazy part on the left. It's just showing the normal part on the right.
I don't know why. Kick it.
Yes, do it.
Other questions? Caleb, mine took a little while before it did that. Like when I initially graphed it, it did not have that on there. It took a while because that actually takes the calculator a little horsepower to figure out. Maybe you have too many apps on there.
Rocket trajectory.
Okay, other questions on that? Okay, let's go to homework questions, and I'm going to be lazy today and just take them. Just raise your hand for homework questions. Yep, Kiwi. Okay, now I will be honest with you. This is one of the sections that I don't always see the shortcuts when I initially look at the problem. So be patient with it. I know some of you got to experience that more last year than others, but some of these shortcuts do not always have. Oh, Kiwi, I didn't talk about. Let's talk about it. So the limit as n goes to infinity of 1 plus 1 over n to the nth power. What's that?
I don't understand how.
Put this in a textbook.
Yep. Well, let's write it out. Let's see what it does. So let's plug in n equals 1. So 1 plus 1 over 1 to the first power, which is going to be what? 2 equals 2. Okay, let's plug in 2. 1 plus 1/2 squared. Plug that in here. So 1.5 squared gives you 9/4, which is 2.25. Yeah. Okay, 1 plus 1/3 cubed. Somebody throw in their calculator. I think it's 2.4 something. Somebody throw it in. 1 plus 1. 2.37. Okay, now here's what you notice. As it gets larger and larger, it looks like it's going to go towards 3 or 4. This is one of the ways of defining what E is. This is one of the ways of defining what E is. Caleb has been insisting about talking to you about the the arithmetic sum that leads to E. There is another way of defining that too, which basically involves a derivation of this. But they just want you to know, like, that's one of the ways to define what E is. And yes, that is in the section, even though I forgot to talk about it at the end. Caleb, that is not testable though, Kiwi. That is not AP testable. That's just like an FYI cool thing. It's just cool, like, oh, that's E2. Like E is all over. And here's the weird part. Differential equations, if you remember that from last year, basically everything from diff EQ gets E to some power. And then you start thinking like, wait a minute, the snow is falling. The ice is melting. The salt is melting with the ice and snow. And the rate is dependent on E? Like whoever you believe invented the universe, E, they're a big fan of E. Like they used it a lot. That's like their number that they use to like make natural phenomenon work. Yeah, like that's, you know, if you get out and you die and they ask you a pop quiz and what's the answer, like if you don't have any clue how to do it, guess E. I'm guessing that's going to be a popular answer on that quiz. Yep.
How would you actually evaluate that limit?
What's that?
How would you actually evaluate that?
Oh, you have to use numerical analysis.
Oh, let's do it. Oh.
That's like a 400 level math class.
But I have another question.
Yes.
Isn't E the number that you get if you were to take one unit of currency and compound its interest continually?
Continuously, yes.
Continuously, yeah.
Yes. That would be the limit
That's what it approaches.
as the number of compounding periods goes to infinity. Yes. Next question.
Isn't E like 1.7?
2.78. No. Hold on, Ayana. Not equal. It's approximately. Use the big words. It's approximately, yeah, 2.78. It is a number, yeah. It's an irrational number. Yeah, it's like pi. Irrational goes on forever. It just, like in natural phenomena, that number shows up a lot. Like a crazy lot in things that have nothing to do with E. So that's why I'm saying whoever invented the universe, like they were a big fan of E. As we find more and more out about how he or she created the universe, like we're finding out like E was a popular answer to a lot of their pop quizzes. Questions on that?
Who discovered you? No.
I don't actually, hold on a second. I don't know. Just a second. Ayana, go ahead.
Can we just compare the answers the class got for them instead of like going over them? Because there's no like answer set yet.
Bernoulli. Caleb, you're wrong. Bernoulli.
Bernoulli.
Wow. Yep. Like compare the answer. Have I not sent you guys the answer keys out yet?
No. So I just want to see if I got them correct. I'm not sure.
So let me remind you, when you guys take your daily quiz today, I'll do that. I have them. I'll send them out to you. Yep.
Why is he everywhere? Do we know? Or?
I don't know. Okay, Cameron, if I had that explanation, I'd be like a theoretical, like theologist / physicist. Like that is a very high level question. Another questions. That's a very deep thing to think about. 45. 45. We got to find the derivative. Ooh, that's an ugly one, Chattery. 45. X, ln y. Guys, stop talking. Y, ln x is equal to 2. All right, this one we got to find y prime, which is dy dx. Now, I always say this. AB took their test today. I was telling them, so you guys can see how far ahead you've already gotten of the AB class because you took the limits test at the same time. This particular one, when I look at this, what rules am I going to use? Product, implicit, natural log, chain. Yeah, because the chain will get us the dy dx here because you got to take the derivative of natural log, then derivative thing inside the natural log. All right, product rule. So the derivative of x is 1 ln y plus the derivative of ln y is 1 over y dy dx. Who's ever talking? Stop. Multiplied by x. That's just the derivative of this part. The derivative of that part, well, what's the derivative of y? Dy dx times the second plus the derivative of the second, which is 1 over x times y is equal to 2. Now, kind of weird. Do we have a y equals equation in this one? No, we don't. Oh, I was going to ask that question in just a second, people. Jeez. I made one mistake and people forget about it because they're so enthralled with the left-hand side, they forget about the derivative of the right-hand side. But obviously I can't pull much on some of you. Do we have a y equals equation in this one? So you remember the y equals x to the x, how at the end we substituted in what x to the x was? We can't do that with this one because this one is implicitly defined. It is not directly defined like y equals this thing. This is implicitly defined with both x's and y's. So we can't do that on this one because we don't have a y equals equation. Could we solve this for y? Not in like a reasonable amount of time, so we're not going to do that. Okay, so let's clean up real quick. ln y plus 1, what is that going to be? X over y dy dx plus, what do we got here? Dy dx ln x plus y over x is equal to 0. That's all the calculus I got to do this one. Questions on that so far? Questions on that so far? Everything after this is algebra. This is the calculus part. Everything after this is algebra. So I'm going to take everything that doesn't have a dy dx. I'm going to move it over to the other side. So I'm going to minus ln y. I'm going to minus y over x. I'm going to minus ln y. I'm going to minus y over x. Let's stop and check up. I haven't talked about that. Questions on why I do that? you remember doing this last year? Okay, yeah, this is just algebra tediness. This is nothing challenging, just tedious. So I've got x over y dy dx plus dy dx ln x is equal to negative y over x minus ln y. I don't know why I wrote that one first, but I did. Yeah. Could I take a negative out of that? Hey, how are you?
Good, how are you doing?
Miss everybody's favorite person, Mrs. Cruz. How are you?
Hey, guys. Good, how are you?
Good. Are you? You're here to interview for the math job.
Yeah, I'm math. No,
You want to next period?
I'm on fall break.
Oh,
Wednesday, Thursday, Friday this week.
gotcha. How are you?
Bye, say hello.
Give me a hug. How are you?
I'm good.
Nice to see you too. Really bummed that guy from Rampart didn't want a job. Grr.
I think he might come to work for us because we do Social Security. He wants some Social Security.
Rub it in a little bit more.
Yeah, but I don't have a job.
What?
You did. I don't have a.
Oh, I thought you meant Cheryl Cruz doesn't have a job. Gotcha. I was like,
All right.
gotcha.
Have a great day.
You too.
See ya.
Wait, where's she at?
She's at a charter school in District 40. It's the TCA of District 49. Okay, people, that's the dean's job. Her job is to be the mean guy. You know how like Mr. King gets to be the nice guy? The dean's job is to be the mean person. Like that's their job. It's all they do all day. If they're not doing their job right, you wouldn't like them. Like that shouldn't be a person like, man, I love the dean. Like I can't wait to get sent. No, their job is to like deal with tardies and parking tickets and like all the stuff Mr. King and Mr. Bramschreiber don't want to deal with. Like they're just like, hey, we got some student who's smoking meth. Dean, go deal with it. Hey, we got some kid that's crying in the hallway. Go deal with it. So yeah, that's their job. She's a really nice person. Like she's really, really nice. I miss her. Okay, what do we do next? dy dx, right? Pull it out. dy dx. I was being serious about offering you the math job too. For the right person, yeah.
Is there a sub right now?
Yeah, Mr. Bear. You guys have had him if you've had me in the past. I mean, he's good, and he's like prepping lessons and keeping the class going. Yeah, last time. Yeah.
Oh,
Yeah, he's really good. He just doesn't want to work full time, and I don't blame him. If I was retired, I wouldn't either. So then what do you do to finish it off? We've got dy dx times this. To get rid of this, we have to divide both sides by that. Now, a lot of people are going to say, okay, I've got very similar answer, but my negative signs are reversed. That's usually an indication that you got to correct. The appearance of these problems take for freaking ever to grade because people can do them a whole bunch of different ways. But dy dx is equal to negative y over x minus the ln of y over x over y plus the ln of x. Whew, that is ugly. Now, question, could we find the second derivative?
Oh, no, thank you.
We could. Horrible, horrible, horrible. But yeah, we could. We can't. The second derivative actually might be a little bit easier to find than the first because now you've got dy dx on one side and everything else on the other. And yeah, that's not so bad to work itself out. Willow.
Is this one of the cases where you just leave it like that, or would they want you to get the fractions out of?
Yeah.
If they gave you this on a multiple choice question, they would not have it work out so horrible. In fact, Willow, when you guys are working on your daily quiz, I'll try to find an example of one out of the practice exams that would give you an answer of what they would want you to do. Or actually, let's look at the APs. Let's look at the AP ones of that. Are there any implicit ones in there? Nope, 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 nope. I'll find one, Willow. Other questions? Has anybody not got this yet? Does anybody need a copy? Because I have way more of these than I should. Some of them were left over from last year. Some of the kids never used it, so they donated it back to me, but
Are we supposed to use it?
not yet. But so basically I gave them to you to get them out of my room. At some point I will tell you every day we're going to do warm-ups out of this. And then most of you just keep your book here. But I didn't have room for it at the start of the year. If you're done with the whole book, that's because you learned everything we're going to learn next semester already. I'll find one, Will. And I also needed to send out the answer key. All right, one more. Pick out a victim here who hasn't talked much today. Arabella, I always ask you to shut the door. Now you can ask me to do something for you. One more question. Which one are you going to go through? 47? Of course you guys pick the hard ones. Like, why can't you pick easy ones? I'm going to need more paper for 47. And you're supposed to reply back because we're smart. We got it.
Hey, Beckman, I think you might need to have your TA take out your recycling.
Janitors are supposed to, but they appear to be on strike.
Wait, did you get this?
All right, Arabella, which side's easier to find the derivative of, the left or the right? Yes. Now, question: what rules am I going to use in this one? Log, implicit. One more. Power, and then yes, also chain. There's four different rules you have to execute in this one. So let's go for it. First, the derivative of natural log is 1 over that thing times the derivative of that thing. The derivative of x squared is 2x. The derivative of 2y is 2y dy dx. The derivative of the other side, what's the derivative of x? What's the derivative of y dx? No, you're supposed to say it's just y, Beckman. What's the derivative of y? dy dx. Okay, now stop and check out. Questions on this? Is this one pretty? No, the algebra on this one is nasty. That's why I knew I was going to need an extra sheet of paper for this one. This is nasty algebra. Stop and check out. This is all the calculus, though. Everything else is from pre-calc, so you can blame your pre-calc teacher for this part. Okay, now let's solve it. Okay, what do I do? Idea, Stefan. Yeah, only thing you can do, because you got to get this out of there to get all the dy dx's on one side, everything else on the other. So we're going to distribute this horrible, nasty thing. What's that? Oh, okay. Okay. All right. Multiply both sides by x squared plus y squared.
Well, that's the only thing you can.
I would have distributed. I'm not saying. Okay, these are both nasty. One's not way better than the other, but this is interesting. I'll do it that way. I didn't think of that. Plus, I like doing things different ways because I get bored of doing it the same way. So that'll leave you 2x plus 2y dy dx over here. Over here, well, let's FOIL that out. What's 1 times x squared? X squared. What's 1 times y squared? Y squared. Dy dx times x squared plus dy dx times y squared. Interesting. All right, now let's move everything to one side. Let's pick on a victim who hasn't talked much today. Who hasn't? Kyle Clancy, which side do we move everything? Move all the dy dx's to the left or to the right? To the right. Why'd you choose the right instead of the left? Right, and that's the only reason. There's more of them on the right. So minus 2y dy dx. Minus 2y dy dx. Okay, minus x squared, minus y squared, minus x squared, minus y squared. Yuck, yuck, yuck. 2x minus x squared minus y squared is equal to negative 2y dy dx plus x squared dy dx plus y squared dy dx. Yucky, yucky. Questions on that? Yes, I am.
When I did it, like after the first step,
Yep.
we got 2y dx times 1 over x squared plus y squared.
Yep.
I made that into 2y over x squared plus y squared dy.
And that's exactly what I was going to do. And then Stefan said, do that. And I'm curious to do it another way. One of them isn't right and one of them's wrong. I'm going to see if this one's easier, which actually kind of looks like it's going to be. Personal opinion. Where are you? That's like arguing about who's better, who's the second best school in D20, like TCA or Liberty. Like, who cares? DCC's number one. It's an irrelevant argument. Not Liberty? What would you go for number 2? Rampart? TCA?
No, there is no number 2. Just
Yeah, they're all tied below us.
Tied for last. DCC and tied for last. I like the way you think about that.
Or tied for second, not
Just TL.
Too low?
No, tied.
Oh, tied for last. Okay, so I'm going to take a dy dx out of this, which is negative 2y. This is 47. Negative 2y plus x squared plus y squared. Divide both sides by that. Divide both sides by that. Okay, so then dy dx is equal to 2x minus x squared minus y squared over minus 2y plus x squared plus y squared. Question, do those y squareds cancel out? No. Don't you wish? Now, question, if you have the same answer but all of the signs reversed, are you correct? Yes, that just means, remember we moved it over here. I asked Kyle, I think, what side to move it to. That just means you moved it over to the other side. That's fine. That's all it means is you moved it over to the other side.
Can I read my answer again? And you tell me it's correct?
Sure, go ahead.
So I have 2x minus 1 all over 1 minus 2y over x squared plus 1 squared.
Oh God, that's ugly, but yeah, that works. That is, whew.
I only have like 3 steps. I combine the two and then I just have
Yes, and I always show fewer steps that I work with them when I'm teaching it, because if you don't get it and I skip a bunch of steps, it's unlikely you're going to get anything out of it. All right, take your desk, back and length in between you, the person sitting next to you. I don't have a TA today, so we're in the honor policy for homework.
Okay, I have my graph paper now.
Luke, you did miss the proof of dy dx of x to the x, and you will want to get that or watch that. It's beautiful. It's a very attractive math problem. If that math problem moved to our school, she would have a prom date already. All right, here we go, ladies and gents. Number 1. Oh, should we go for easy or hard? Let's go for hard. Number 1. Oh, beautiful, beautiful, beautiful.
Ooh, wait, okay. Oh, what?
That's trivial. Doesn't even have a double chain rule in it. Then number 2, y is equal to. I love this problem. I was shocked nobody asked it on the homework, so I'm going to ask you to do it. The natural log of x.
That was an almond.
Sure.
Yes.
Okay.
I did my
Well, that's too bad for you. Okay, so number 3. Weight. Y is equal to. Oh yeah. I like this one. Yeah, I like this one. Sine of the natural log of x. Whole thing squared. Oh yeah, find dy dx for all of them. Thank you, Riley. Was that not Riley again? Y'all sound like Riley. That's it. That's nice. That's it. I'm going to get some trig derivatives today, so that's it. Ready, set, go. I'm going to call your name. You may do one of 2 things. You can come up and show me your homework, or you can tell me how many problems you did not do. Did not do. By the way, I heard a lot of you are babysitting tonight at NHS. Can any of you tell me if you are? My son will be there. My son's name is Ben. Today is his 7th birthday. He doesn't get to spend much of it with his dad. Be nice to him. I know, so that's why I was late to school this morning, is we basically had to do all the birthday stuff before school started. So I had to get him up.
Another day?
What's that? Oh yeah. Are you kidding? He had his birthday party at the Air Force Academy hockey rink in full CC gear. He even told the guy when he checked in, he's like, this isn't the only time CC is going to be scoring a bunch of goals here this year. He's okay. My son is way cockier than most 7-year-olds are around adults. Like around kids his age, he's very nice, very polite and everything, but he's around like high school kids / adults so much that he's really used to talking around them. So he isn't afraid to talk smack. Like if any of you ever been in one of my first period classes when he's hanging out here, he basically thinks he's one of them. Like he'll go, like anybody ever been in a class that he's went in and like giving you high fives on test days?
Oh yeah.
Like he likes to walk around in the mornings, and if he sees somebody's got a test, he'll like walk around and give you knuckles, like good luck, good luck, good luck.
If you must tell an FST kid like the answer to it, like what's 5 + 2?
Oh no, let's pick on some individual kid because I like to do this.